Alright, what's going on? I know for you guys that aren't super interested in the project, you're probably getting tired of all these videos, but I've literally had no time to work on the Jeep, so this is what I get. I figure for the small crowd that does like to watch this is better than nothing. So, exciting news, we're finally out of version 0.6 and into 0.7. So I figure now is a good time to switch things over. So in the vehicle, now we have a selection screen, so we can edit our baud rate if we need to, and shit like that. So, but it depends what I find, if this is even going to be useful for now. This is kind of just an alpha stage thing. And same with the program number, so we can, change that, because that might be different on different vehicles. So, the biggest exciting thing for end users is just that the spacing is the same now. So before I was having an issue, these are left justified, which is a pain in the ass when you want them to stay still, because if you add a number to the end, it pushes it over. So what I had to do is move the start point over and then do a couple checks. So if the number was less than 10, add a space. If the number was less than 100, add a space. So that way, as these move, it adds spaces to compensate so that it keeps them in the same spot. There is a way to program it to like right justify, but it's not very well documented. It's a real pain in the ass to get it to right justify and not scroll to the right. So what that means is everything would come out backwards from the right, which is not what you want at all. I don't even know why you'd ever want that. But yeah, so whatever. Now everything is in the same spot, so it's all good. So yeah, these are pretty much ready to go. First question for people that are interested: what color buttons would you want? Would you want black, red, or white? Black's the cheapest, red is cheaper than the white. The white's real expensive, but I don't know, I gotta order them and see. The only reason I say that is because when this case goes on here, they blend in a lot. Like, it's really hard to see the buttons. So yeah, they kind of don't stick out much, so that's why I'm thinking a different color. I kind of like the idea of red. I mean, I could always leave the option up to whoever wants to buy it, but it would be easier on my end if they're all the same color. Now, as for alpha testers, I'm happy that you guys are being patient, because, again, I'm not completely ready to send these things out yet. I only got 9 extra boards. I'm probably going to keep one for myself, or maybe 2, so that leaves 8 of you guys up for grabs. I'm not going to lie, those of you that have a 1989 4.0 liter auto vehicle have a slim chance of getting an alpha model. I am going to send 1 or 2 or maybe 3, but the whole point of the alpha stage is to make sure that this works on different vehicles, and years and transmissions and stuff like that. So like 90% of the people have the exact truck I have, which doesn't help me out for the alpha stage, but you'll definitely make great beta testers. That's not saying you won't get one, but your chances are lower if you have that combination. So the only thing I'm waiting, I need to go to my friend's house and see what his Jeep does. I finally got that logic analyzer, and I'll show you how that works later. But yeah, if I can see what his Jeep is doing, and it's a simple thing, like if it's just a baud rate change or something, then we're in the money and I can start sending these out. And I'm really excited on that, but I'm waiting for his lazy ass to wake up. So the other thing I need to do is finish the case. So here is what I've got going on so far. We got the outer piece, and then, a back piece. I'm trying to work on snap fit, because that shit ain't easy. So we have like a little, thinger-dinger, and you got a thing, and it does the stuff, and it snaps into place, but I need locating tabs, and also the snap fit isn't strong enough for how big this case is. It's real easy to pull it apart, and you'd accidentally pull it apart all the time. So I'm thinking either scrap this idea and instead have a backdoor system that slides on, kind of like how this one works, so that, it just slides on and snaps into place, so that way you can pull on it pretty hard and it doesn't come off. So I got to play with the case. The other idea is holding the board in place, because that's another issue, is physically keeping the board inside the box. I left holes for like screws, but I don't know how well it would work, and that's a tiny thing to... tolerances, man. So I got an idea from one of the cases I printed out. It was too tight, but it was kind of a good thing, because the board actually snapped into place. So it kind of gave me an idea of a friction fit design. So I made these little tiny nubs, and the nubs should hopefully hold it in place that way. So I still got to get the spacing just right. I need to leave a little bit more space for this to properly do. But by using a friction fit, that should hold it in place pretty well. And when there's more plastic, it should hold for how we need. Because right now it's just kind of distorting it a bit. But that's an idea I got going on, is a friction fit so it stays in there. So yeah, once I get the case fully figured out, and I figure out what my friend's Jeep is doing, I'm gonna start sending these out. So if you do want to be an alpha tester, I'm gonna. These alpha models are going to cost $50. So if you have a PayPal account, that's great. I'll ask for a payment, and the $50 is to cover the cost of all the parts and shipping. There's not really that much money being made. There's only a couple bucks being made off the things. That's just to keep it simple. So yeah, it'll be $50 for the alpha models if you're still interested, and stuff like that. So yeah. Alright, well, now for the topic of this video, let's learn about logic analyzers and maybe see what's inside the transmission computer. Ooh. Alright, here we are, the bootleg of bootlegs. So here we have another eBay special. This is I have no idea how to pronounce this thing, but a Salilibid logic analyzer. Now this is just an eBay knockoff. You can get these for $11 shipped to your door. And good God, if you get these things from DHL, you're going to be waiting a while. But yeah, it's hooked up, and I got it running off the Uno, and I'm just running the stream as it kind of would be. And I got their software hooked up over here so we can see what we're looking at. And we get stuff. So this is the ups and downs and all that good stuff. And what we want to do here, I just maybe kind of figured this out. Hopefully each one of these is what is that, a bit? Yeah, it's a bit. So if you notice here, it says that our bit width is 16 microseconds. So we take that number and we do a little math to it. You divide it. So you do 1 divided by 0.0000, and then your bit width 16. And look at that, the magic number, 62,500. So by doing that, we can find our baud rate. Now it's weird because sometimes these are a little longer, like that one says like 16.04, so the Arduino might not be doing that perfectly, but you want to find it where it's just a bit going from 1 to 0, because if like it's this one where it's a bunch of zeros, then it's going to be different. But you get the idea. So this little device, it might not be perfect, but it does what we need to. Okay, so if everything goes well, we get our analyzer hooked up to our old school breakout board. Then we get the Arduino being powered, and that's literally just being used as a 5-volt source and the transistor flippy. So if all this works, we should be able to click start. I think everything's working properly. I'm getting some interesting results here. So if we zoom in here, you notice there's a lot of space. So it'll send a byte, and then a huge space, and then it'll send another byte in a huge space. So I guess that just makes it a lot easier to figure out where they're at. So that's interesting. But if we come in here and see our idle line is 2.7 milliseconds. And then here we got 15.42, 16.58, 47.42. They're all over the place. 15.42. And then there are 2.752 milliseconds between. So that's very interesting that there's such a big gap between bytes. Now that must be what it does when it's not running, because it has that giant gap. So actually, I'm curious now what happens if we start it. Okay, so here we have our second reading, and this one was with the engine running. Apologize, this whole white on black thing's a little hard to read. So now if you notice, our bytes are a lot closer together. This is more of what I was expecting, is something like this. So it's interesting that when the vehicle's off, there's such a big space. Yeah, this is the first time I've ever even seen stuff like this before, so like, I honestly don't know what I'm looking at. I just know it's stuff. So, this is what it looks like when the vehicle's off. I just wanted to show you now that I kind of understand it. So you can actually set up the baud rate so it reads the bytes properly. So it'll tell you in a decimal what each byte is. And if you zoom in, you can see each part. So you got like 0, 0, 0, 0, 0, 1, 0, 0, and then that's the end. This start one, when it first goes low, this is the initial start bit, and the stop bit is just part of the idle stream. It's just as long as it needs to be. But I just found that it was interesting that when the vehicle's off, there's a huge gap in between these things, and this is part of the reason why it runs the sketch runs slower when the vehicle's off, because it physically takes longer to read in each byte because these giant gaps. And if we come over here, we can see the list that we're used to. So if we scroll down to, here we go, here. So we got our stop byte, our start byte, and then our program number that we're familiar with, and then the data, and blah, blah, blah. So yeah, that's what it looks like when it's off. And then when it's on, things get a little more interesting. Now, at first, I thought that each one of these was an entire stream, but that's not the case. It's only like most of the stream, or a little bit of the stream, and then a little bit more. So it's not perfect. Sometimes it's 35, sometimes it's 36. It's just, I don't know, it's a little random. But the pattern's always kind of the same. You got a gap, and then you got a byte, whatever that byte might be. And then we got another gap, and then we have a whole bunch of them all in a row, and so forth. But it's still the same technical speed. There's just smaller gaps between each byte. But it's just interesting to look at what this thing is really doing behind the scenes. But if we come down here, we still have our same pattern. So we start off with our 255, a 0, blah, blah, blah. So yeah, it's interesting what you can actually uncover with this kind of stuff. And just in general, if you've ever been trying to figure out how to get this stuff, you go into your, you add an analyzer profile here, and then you can set the baud rate. And usually you don't have to mess with any of this other stuff, and you hit save, and it'll automatically find all this. Okay, so obviously we weren't getting a signal using our ECU thinger on the transmission side, so it looks like this is a little bit different. So the other thing that I can think of is with the ECU, if it's an open collector output, that means that it's floating when it's off, and then it goes to ground when it's open. So if you do a continuity check between the TX pin and ground, you should get continuity in bursts. So if we come over here, from our ECU TX pin to our ground, we're getting 154 ohms, something like that, because it's pulsing on and off between that and ground. Now if you put it in positive, it just goes beepy beepy, so I don't know. We don't really get much. So let's do the other thing, the other side now. So let's take our positive and go to the transmission TX pin, which is the direct opposite, and we will go to our ground pin, which is the farthest one from the TX over there. Okay, so now we're in transmission and ground, and we don't get anything. Nothing at all. So that means that this is not being pulled low. Now the other thing we can do is check to see if it's being pulled high. So now I'm going to take that black one and go from the negative to the positive, and if you hear that, that's a very distinct pattern. So I think that means that it's being pulled positive, and it needs a ground reference instead of a positive reference. So I guess that's a pull down resistor. So I'll have to look into what is required to make that kind of circuit, and then once we figure that out, we should be able to get some infotation. Alright, so I've been digging around with this for a while. I asked for some help online from some people, and I got a couple suggestions for this, that, and the other thing. I found some diagrams of the transmission computer and tried to dick around with it. But honestly, I figured most of the important stuff out with my multimeter. Switch which one was red and which one was black. And I noticed I got a long continuous tone. But if I take that black and go to positive, we get a full tone. If I went to TX to ground in a certain position, it seemed like I got some decent data. So now the negative is going to go to the TX, and our positive is going to go to ground. That gets us the signal we want. So all I really did was I took a transistor and I ran the base through a resistor into the TX pin, and then obviously the base goes to ground, and the ground is just connected to the car over here. And by hooking the logic analyzer up to the collector, which is using a pull-up resistor over here, so when the TCU pin goes high, it brings it to ground, and when it's not high, the pull-up resistor pulls it up to 5 volts. And I actually got stuff, which is kind of cool. The first time I tried it, it said that there was an error and it like couldn't keep up with the device or something. But we actually got information, which is cool. And these beeps, you can actually hear it go brrrt, brrrt, brrrt. So I figured there was something there, and lo and behold, there is. So I get some stuff every now and then. When you zoom in, it's real tiny. So, holy crap, really? That's nanoseconds. I wonder if that was a mistake. That ain't much. I've been used to working with microseconds, so either that was a hiccup or... Because that's only half a microsecond right there. It's 5.125 microseconds. I don't know what the hell this thing's doing. So these bytes? Is this a timing signal? What the hell am I looking at here? I have no freaking idea what I'm doing. Okay, so I uploaded a sketch. If the baud rate over here, what did we figure out? It's actually 2 milliseconds, not 2 microseconds. So that comes out to a baud rate of 500, which is slow as all hell. So if you come over here, you can literally see them being slowly printed. And we do have a repeating pattern here. I don't know. So I may have stumbled onto something. Maybe. Oh, dude, this stuff is so fucking confusing. Okay, so here we are in the daytime. Tell me I'm not going nuts. Am I going nuts? But now we don't have those little weird dashes anymore. It's a clean signal. Now, I did drive this today, so I don't know. Maybe it just needs to, warm up and then it's all happy. I don't know. But it's got the same pattern still. Actually, really quick though, I'm going to turn the comfort switch off and see if that changes one of our readings. What do we get? Aha, look, we got a different number here. 241 instead of, what was the other one? 113. So this is our power comfort switch, I guess. That's nifty. Okay, so now for the real test. We're going to start it and see how much faster it goes. Alright, get a start. Hopefully it doesn't vibrate too much. We get a couple errors there, just because she's a little shaky. Let's try it again. Much different. Some framing errors. Shut it off and take a look. So what is going on now? Now this is completely different. Let's see if we can find a good bit spacing. Still has the same bit length, but there's a couple of framing errors. Like right here, there's a framing error. Couple framing errors. What the hell? Yeah, it still gets this stupid little thing right here. And it thought that was the beginning of the bit, so it starts it there, which really screws up the timing. So it could be that the method that I'm using to trigger isn't as good as it could be. There could be a possibility that the transistor switching I'm using, there could be, I don't know, some transient voltage, or I don't know how they turn on or off, or how any of that shit works, or I don't know, man. I ain't some kind of genius. Alright, I think we finally done diddly did it. So I looked into something called a low-pass filter, which is supposed to take out the higher frequencies but let the low frequencies through. Because that's what we're having is, we're having a really high, a really quick pulse, which is giving us issues. So if we could just smooth out that little bit, but, still keep enough that the other things can work and do their stuff, then we all good. So all that I added to the circuit here, I tried using a low-pass calculator, and, I tried getting like a 28, K resistor and a 104 picofarad capacitor, and supposedly that would block like a ridiculously fast hertz range. I forget, it was like 50,000 or something. But we were only trying to block something that was less than 15 microseconds, so that should have been fine. You can do microseconds into hertz, which is interesting. But the problem is that 28K resistor which would go right here, wasn't properly turning the transistor on and off. So I had to go back to the 3.3K resistor, and just for shits and giggles, I put the capacitor back on, and all that does is it goes from the base to ground, and it works. So if we come over here to our data, this is with the engine running. No more blippity bloppities, just a clean signal. Now because of what I'm doing, it's changing the byte length a little bit. So now the total byte length is 17.58 milliseconds, whereas before it was 18. So it's slightly shorter by half a millisecond, but that's not a problem because if you look at the length, it's still fine. If we go check something a little more interesting like this guy, all the dots still line up properly. Now if we go over to the transmission, there's a couple interesting things here. So this is what I got from the transmission. Now this baud rate is ridiculously slow. I was not actually prepared for how tiny this is. Like, each byte is like 2 milliseconds. Compare that to the Jeep ECU, where each one was 16 microseconds. This is a huge difference in time. This is a really slow stream. But if we come over here and edit the settings, I found that the baud rate's basically 500. I've been messing around with little numbers, and it doesn't really seem to change at all. So we could set it to 500 and save, and it still does just fine. But the transmission makes a lot more sense. So if we come over here, we have a 10024119200, and one of these is for the power comfort switch. I found one was for the TPS sensor. I think one is the speed sensor, and then we got some other stuff. The last 0 is an error, so if it goes 1 or something else, it's different error codes. I don't think the 1 changes, so that might help us out, but yeah, this one makes a lot more sense. You get all your bytes, and then you got a space, and then all your bytes, and it just, it kind of makes sense. Now the weird thing is, with the way that I'm reading in the code, I started getting all these weird like dashes. If I go to this one, here you go, here's a good one. This, I was trying to figure out what the heck was going on here. In between like each byte, there was like almost a perfectly spaced thing, but it's not quite the right length. But if we come in here, you notice that these are milliseconds. You see this weird thing, it's a couple microseconds. And even like, look at this little change right here, this is really tiny. So I don't know, it's just weird that there's these little tiny hiccups here and there. I don't know what the heck that is. I don't know if it's a byte or maybe it is. The spacing's all wrong, it's completely random. So I don't know what's going on there. So what I had to do is use a capacitor to try and filter these out. I made like a low pass filter. I tried doing the math, but the math didn't quite make sense, so I don't know. I just kind of stuck stuff together until it worked. So I would get these issues with the vehicle running, but usually not when the vehicle was off. Now if I try to apply the thing to it, we start getting framing errors, because right here it looks at this dash as a low and it thinks that that's the start bit, but in actuality this over here is the start bit. So what it's doing is it's starting at the wrong spot and getting all this wrong data. So yeah, we were getting all kinds of weird goofy stuff because it was accidentally triggering when it shouldn't. So if we go over to here, now we have the capacitor set up and now we have clean data. Anyone that's familiar with stuff like that, if you have any information that you can tell me about this, that would be wonderful, because I'm damn near completely clueless with all this stuff. I'm just like guessing as I'm going. Alright, so I got everything on the test board over here, transistor to resistors and our capacitor, and we're all hooked up. So we're back to the test adapter over here. Well, that's a bummer. Why you no print data? Alright, it'll take a little more playing around then. Well, either my code's fucked up or something else is not right, I don't know. So I hooked up to the board the way that I did before with the logic analyzer, and well, it reads in perfectly fine to get our 100, 113, 192, 00. So what the hell, man? Okay. Oh, now you're gonna stop. Now you're gonna stop. Really? Okay. So check this out. I was gonna hook up my my analyzer to this thing. Now, I'm going to get kind of funny readings because there's no LCD clear command. But if I just touch this here, it'll start reading. I'm so confused. This stuff, things. I should put an LCD clear in there though. Seems like it might be losing track here. Come on, you bastard. You're really pissing me off. That almost had a good pattern there for a second. Without having a true oscilloscope to see what the voltages are doing, I have no idea what this thing's doing, and it's all guess and check work. This sucks. Okay, so I got an idea. I was wondering if maybe the highs and lows weren't being triggered properly. So what I did is I took that TX pin that I made, and instead of sending it to RX, I'm just sending it to an analog in. And, I'm just checking the analog voltage to see if we're getting our proper high and low. So I got this set to a really fast speed, 115,200 baud rate. So as we can see, it'll stay 5 perfectly fine. So the pull-up resistor, is working perfectly fine. And then when it drops down to 0.27, 0.26, then comes up to 5, and it'll drop back down to 2.7, 2.6. So I'm wondering if that's an issue, if it's not a perfect 0, if it doesn't read that as a low. I don't see why not though. That's pretty low. If you get something in the middle here like 3.3, a 4, I wonder if it was like reading like halfway through, or if it's just a bump or something. This would be where if you get like an oscilloscope or something going on, you might be able to get a better idea. See if maybe the waveform isn't quite square, or the timing's off, or who the hell knows what. But I don't know. That doesn't seem half bad. Okay, so I remember I was getting issues with if I touch the logic analyzer to the same thing, that I would get a different output. And I finally checked it on here, and the 5 volts actually dropped down to like 2.1 volts. So our high was only 2.1, and our low was still 0.3. So I decided to check the ECU side just to see what that was doing, because I know that this one works. And this one, it looks like you get a perfect 5 volts, so it's being pulled up properly. And when it goes low, it goes down all the way to 0.03. And you see that a couple times. So that's a very defined high and low. That's almost perfect. So that's interesting. Okay, so we get some good news. So I tried dicking around and figuring stuff out, and I didn't really see anything because it seemed like we got a good high and a good low, and the logic analyzer picked it up and all that. So I was wondering if maybe the RX, like the actual hardware UART on this thing was just giving me issues. So I said, screw it. We're not going to be using that anyway. I'm going to be using software serial. So I went on over to here, and I just did a simple software serial setup. So what this does, instead of running from the UART pins of 0 and 1 for RX and TX, you actually just get to set your own. Some Arduinos have limitations on what pins you can use, but you just come down here and call it something. So we called this one port 1, and you have your 10, which is our RX, and 11 is TX, I believe. So we come down here and start our normal serial begin, and that's the one the computer reads. And then down here we can set another one, which would be port 1 for 500. And then you just tell it to listen so that it actually starts, reading. I think that's kind of like serial.begin. And then you just set up, a variable to a read, and then you print it. So if we come over here, things are flying past, but if we stop the auto scroll and take a look, we go 0, 0, 1, 0, 0, 113, 192, 0, 0, space. Yeah, buddy, that's the data. Oh, God, that's so cool. Okay, so now that the Arduino is properly getting the data, now I think I could run a sketch to tell it to find the stuff and things like that. Oh boy, the rabbit hole just keeps getting deeper and deeper. But look at what we got. This should look a little familiar. 100, 113, 192, 00, hike. Or the other one that's kind of just junk, cabbage. Okay, so it actually took quite a lot of fucking around in order to get this to show up, because for some reason it was going to be, it just decided it's going to be a little douche. For some reason when you read in the data with, I'm like hacking into Phil's code and turning it into my own purpose for this, but for some reason when it reads in the buffer, you get a bunch of 255s in between the good stuff. So it'll just say 255 a bunch of times, and then you'll maybe see your first number once, and then some more 255s. And that might have been akin to what the serial monitor was showing when you kept getting -1, -1, -1, and then your data. So I had to make a little code to filter that out. So we're still using the same setup he's got here. Checks to see if the buffer is greater than 7. If it is, we use, I don't even use the previous equals current, because by using current and next, by using peak, you're not actually reading the thing, so it can display the one it first read. If you do previous current and then current, then the previous one is lost. So if we just come down to our if statement, if current is equal to 0 and next is equal to 1, because if we go over to here, our ending is 0 and our beginning is 1. We don't need a third because this value is going to change, and this is small enough we can't really afford to search for a third, so we get rid of that next if statement. We just go into what we need to. I have the LED going high and low, but I don't notice it blinking. Unless maybe... where is that bastard? No, doesn't look like it's blinking. It's pretty solid. I don't know. But anyway. Okay. So we use the same for loop, so for position equals 0, position less than 8, position plus plus. Now here is what we had to mess with here. Generally it was just data stream position equals port1.read. So it would just read whatever was first and just dump it in there. But the problem is we kept getting all these 255s instead of data we actually cared about. So before it's allowed to write into the stream, it has to check if it's not 255. So now instead of just setting the data stream to the port read, we're setting a variable in byte or incoming byte to the read. And then it checks if in byte is not equal to 255, then you're allowed to save it. So by doing that, it filters out all the crap and we only get the stuff we care about. And then we just do some stuff to print it out. I don't know if flush is necessary or not, but it was in Phil's code, so whatever. So yeah. If I wanted to, I could probably add a very short delay. We'll say a delay of, let's make it real short. Let's just make it 1 millisecond, see if that fixes up this blinkiness. So we're writing, we're reading, good, and it makes it a little more legible. Let's bump up to something that should actually affect it, like 10 milliseconds or something. Hopefully that doesn't slow down the read process too much. That looks pretty standard. Okay, so here's the ultimate test. We're going to come over here and mess with the TPS. So the first one after 1 should be our TPS. So we'll get to see... come on, you fucker. Thank you. No. Now it is slow as hell, though. Look at that delay. Jesus. Alright, Houston. I think we have clearance to launch. Oh no. What happened? Well, this is new. The only thing I can think of is that maybe my communication dealio doesn't work well over long distances. Fuck. You were doing so good. What happened, buddy? Stick with me, Jimbo. What happened? Okay, well, I don't know what I did, but, like, now it reads. Huh. So if I push this all the way down, then it turns into a different number. Or maybe that last 0. Oh. Did the other number shift too? Yeah. So the last number is a, maybe it's an error code? Huh. Fuck, so that means I can't rely on that. That sucks. Alright, so we're getting a little bit of junk here and there, but it seems to be doing alright. Come on, focus, you fuck. There you go. Alright. Whoops. Okay, that's actually connected to things now. Alright, well, let's see what happens when we go for a drive. Seems like it's still tracking properly, so that's good. Okay, so I tried hooking up the signal to our pen, and we're not getting nothing. We're only getting 5 volts, which means that the transistor is never being switched on. But if I check from the input from the TCU TX pin to ground or positive, I don't remember which one it is, I still get that signal. So we're still getting the signal properly, it's just not being switched properly. So yeah, I'll have to look into that. So it might be more of a hardware issue. Okay, so just real quick, I want to show you the basic sketch that I have for the circuit so far. It definitely needs a lot of work, and I would definitely not try this as the final product, but it may or may not get you going. The biggest thing that I don't know about yet is the TCU TX output. I don't know what the voltage is. If it's a low voltage, then great, but I'm pretty sure it's battery voltage, and if that's the case, I'm using this transistor as a relay so that the 12 volt and 5 volt, don't touch each other, because obviously, these Arduinos can't handle 12 volts. So I'm just using the relay to turn a transistor on and off. So yeah, I kind of need an oscilloscope or like a high voltage analog to digital converter or some kind of crap to see what this thing's doing. It goes so fast I can't read the up and down voltage properly. On the multimeter I only get like a half volt. So I don't know. Also, the resistor here I think is the biggest issue. I think this needs to be lower. I know when it was 10K I definitely wasn't getting anything. So maybe, a 1K or, might not even need a resistor. I don't know how resistor biasing works and all that crap. So I'm kind of just throwing shit together until it works. But right now, the TCU goes through a resistor into the base. I kind of fucked up the diagram here, so whatever. But, we have a resistor to the base. And what that's doing is when this is going high, it's turning the transistor on, going to ground. And that's allowing this to flow. And if it's not flowing, then we have this pull-up resistor. So on the RX pin, we've got to pull up to 5 volts if there's no signal. And when there is a signal, it goes to ground. So this is non-inverting. As before, when I was showing you on the data stream, those little tiny bumps that are like microseconds, I had to smooth them out mechanically because I couldn't really get the software to read properly otherwise. So I just have a 104 picofarad capacitor going from the base to ground. And what that does is kind of absorb really fast signals, but kind of lets the bigger signals go through, I think. I'm still not 100% sure on this. I think it's a low-pass filter, but the resistor value is getting here is so high I wasn't getting a signal, and I don't know how it all works. So this kind of works. When it does work, it works. When it doesn't work, it doesn't work. So basically, we'll always get the our signal here to ground, but it might not be enough voltage to actually switch the transistor, so sometimes this doesn't switch. So again, this might need to be a smaller resistor, or I might need to do an entirely different system to get this to work. But that's what I have so far, and it's kind of getting me somewhere. So if any of you people out there that know how to actually make proper circuits and shit like that, let me know. Or if you get any ideas, I need a little bit of help here. But that's kind of what I got, and it kind of works, so, yeah.